Hi everyone, I am Dr. Sadish Kumar, Professor, Department of Physics, K.S.Rangasamy College of Technology, Tiruchengodu. Today we will discuss about fiber optics. The fiber optics covered introduction, classification of fiber, difference between single mode and multi-mode fiber, difference between step index and gradient index fiber. The fiber The fiber optics is a technology that transmits data as pulse of light through thin strands of glass or plastic. The advantage of fiber enabling high speed, the long distance communication with less signal loss, immunity to electromagnetic interference, crucial for modern internet. The telecom and networking by using core cladding and coating to reflect light internally. The figure shows the optical fiber. The optical fiber is a two major part. One is the core, another one is a cladding. The core and cladding is a fully responsible for total internal reflection. At the same time, buffer and jacket is the protect the core cladding material from the environment. Total internal reflection is a phenomenon where a wave such a light is completely reflected back into a medium. The condition for total internal reflection: light travels from denser medium to rarer medium. The angle of incidence exceeds the critical angle. The classification of fiber. The classification of fiber are based on three categories. One is the material, second one is number of modes, third one is refractive index. First, the material based is classified into further two categories. One is the glass fiber, another one is a plastic fiber. Number of modes classified into another two categories: single mode fiber, multi-mode fiber. And finally, the refractive index is classified into another two categories: the step index fiber, another one is a gradient index fiber. Now we will discuss in briefly. One is a material. Optical fiber can be classified based on materials into two major categories. The first one is the glass optical fiber, typically made from silica with possible doping material like a germanium to enhance the performance. The second one is the plastic optical fiber, made from polymer material such as polymethyl methacrylate or other plastic material. The second one is the number of modes. The optical fiber can be classified based on the modes into two major categories. One is the single mode fiber. The optical fiber designed to carry only a single mode of light, the transverse mode. The second one is the multimode fiber, the optical fiber designed to carry more than one signal. The diagram explains the comparison of the single mode and multimode fiber. In single mode fiber, the core diameter is the small and cladding is very high. In multimode fiber, the core diameter is high and cladding is very less. Because of in single mode fiber, the only one signal propagated through one place to another place, but in the case of multi-mode strip index fiber, more number of signals is propagated at a time. The third one category is the refractive index. The optical fiber can be classified based on the refractive index. into two major categories. One is the strip index fiber. The refractive index of the core and cladding is fixed. The light ray passes through optical fiber and crosses the fiber axis in every reflection that occurs in the core cladding boundary. In the case of strip index fiber, the light wave passes in the form of zigzag shape according to the phenomena of total internal reflection. Second one is the gradient index fiber. The refractive index is a bit higher at the surface of the core as compared to the core cladding surface. It decreases from the core surface to the core cladding surface. For more clarity, we should say it decreases from its center. The comparison of step index and gradient index fiber. In step index fiber, multi-mode step index fiber, ray paths are different so that rays arrive at different times. In gradient index fiber, ray paths are different but so are the velocities along with the path so that all the rays arrive at the same time. These are the major difference between step index and gradient index fiber. Discuss the other important points of step index and gradient index fiber. In step index fiber, step changes at the core cladding interface, core index is greater than cladding. Then easy to manufacture and less cost. The core diameter is the 125 to 400 micrometer. The coupling of light is very easy. Intermodal dispersion is more as light rays arrives at different times. Draw light propagation in step index. These are the properties of step index fiber. Then gradient index fiber, non-uniform refractive index profile, difficult to manufacture due to gradient index and hence costly. The core diameter is 50 to 100 micrometer. The coupling of light is difficult. The intermodal dispersion is less as all the light's paths arrive simultaneously. Draw light propagation in gradient index. Thank you.